polymerization methods for polyethylene production. So we will begin to introducing the polyethylene and its significance. Polyethylene is the world's most widely used lightweight and versatile plastic produced by polymerizing ethylene units into durable and flexible materials, and is it widely used in packaging such as plastic bag and films, in construction for corrosion resistant water and gas pipe, in medical application including siren, catheters and tubing, in automotive parts like bumpers, fuel tanks and interior components, in agriculture as protective crop films, and in consumer goods such as toys, household items due to its excellent chemical resistance, toughness and availability in different density form such as LDPE, which is flexible, and HDPE, which is rigid. So the first method is bulk polymerization. How bulk polymerization method apply to polyethylene production? Bulk polymerization, the simplest method which has monomer and initiator, which is no solvent, is used for polyethylene production, especially to get pure polymer or unit reactor blends, often involving ethylene gas under heat and pressure, or modified techniques like suspension bulk polymerization for powder form. It's challenging due to high viscosity and exothermicity, often leading to LDPE process or specialized reactors for HDPE. So this is principle of bulk polymerization for PE. Polymerization occurs using pure ethylene monomer only. No solvent or dispersing medium is used. Monomer acts as reactant and reaction medium. Initiated by heat or chemical initiators. Polymer chain grow by addition of ethylene units. Reaction is highly exothermic. In the PE, increasing viscosity makes heat control difficult. The last one is produce high purity poly. Here is the advantage and disadvantage of using bulk polymerization for polyethylene. The first one is a high purity and simple operation. No solvent or dispersion mean a pure polymer with no solvent, removal issue and simple equipment. Second, high polymer yield. High concentration of monomer leads to high production rates per reactor volume. Next, good polymer properties. Can produce polymer with higher molecular weight, potentially better clarity and fewer impurities. And the last one is a lower cost. Reduce energy for solvent. Next, the disadvantage of using bulk polymerization for PE. The first one is a heat transfer difficulty. High exothermicity combined with increasing viscosity make removing heat hard, risking thermal runaway. Second, viscosity and mixing issue. Viscosity rises dramatically, creating the gel effect, auto acceleration, making mixing difficult and affecting chain diffusion. Third, control challenge. Difficult to control molecular weight distribution, MWD, and conversion, leading to broad MWD. And the last one is a scale-up problem. Heat management and mixing issue become severe at larger scale, limiting industrial use for many polymer. High pressure PE is an exception. So here the example product and application where bulk polymerization of PE is commonly used. First one is a packaging film, bottle, wire and cable insulation, and the last one is a...
Hi, my name is Esan. Now we go to emulsion. What is emulsion? Emulsion polymerization is a heterogeneous polymerization process in which the monomer ethylene is dispersed in water with the help of surfaction or emulsifying agent. The polymerization reaction occurs within micelles formed by a surfaction. A water-soluble initiator, such as a peroxide or perosulfate, is used to generate free radical that initiate polymer grow inside trees micelle. Then, how this emulsion is used in production of polyethylene? Okay, in polyethylene production, emulsion polymerization is less common compared to other method, but it used in specialized case where latex type PE dispersion are required. The process allow polymerization at relatively lower temperature and offer good control over molecular weight. Then we go to the essential principle and factor in emulsion polymerization. So the key principle of emulsion polymerization include the use of surfaction to stabilize monomer, droplet, and polymer particle. Then vertical radical adhesion in an aqueous medium, polymerization within micelle not in the bulk monomer, and efficient heat removal due to water acting as heat sinks. But same juga has an important factor affecting the process include concentration of surfaction, type and concentration of initiator, reaction temperature and pressure, and agitation rate and stability of the emulsion. Then we go to the next slide. We have advantage and disadvantage of emulsion polymerization. Okay, for the advantage, it has a excellent heat control, reducing the risk of runaway reaction. It has a high molecular weight polymer can be produced. It has a fast polymerization rate. It produces fine polymer particle with uniform size, and it suitable for producing PA latex dispersion. But for the disadvantage side, its removal or surfaction and residual initiation is difficult. Final product may contain impurities. Drying and purification increase processing costs, and limited use for conventional PE grades. Okay. This type of application that can be used in PE is adhesive and coating, polymer latex, surface coating, specialty film, and emulsion. Then we go to the next slide. It is a suspension polymerization. So, what is suspension in PE production? Okay, suspension polymerization is a heterogeneous process where the ethylene monomer is dispersed as small droplet in water using mechanical agitation and stabilizing agent. Unlike emulsion, polymerization, no surfaction bases are formed. Polymerization occurs within the suspend monomer droplets, and the initiator is soluble in the monomer phase. This method is commonly used in industrial PE production, particularly for HDPE and LLDPE, due to its simplicity and efficiency. And okay, so for the suspension polymerization, we have a fundamental aspect. So this key feature of polymerization include monomer droplets suspend in water, initiation dissolve directly in the monomer, polymer beads form directly during reaction, and water act as a heat transfer medium. Okay, for application, we use in a plastic container and bottles, pipes and fitting, packaging material, household good, and industrial mold product. Okay, for the last, we have advantage and disadvantage suspension. Okay, for the advantage, it has a good heat removal and temperature control. It can produce polymer beads that are easy to separate and dry, have a lower viscosity compared to the bulk polymerization, Minimal contamination compared to emulsion polymerization and suitable for large-scale industrial production. And for the disadvantage, we have requires careful control of agitation droplets. Coalences may occur if stabilization is poor. Less control over molecular weight distribution compared to emulsion polymerization, and use a large volume of water. Okay.
My name is Fashanalisa binti Zarudin. So for the solution polymerization, the method that we use for the production of polyethylene is, in this procedure, a monomer is dissolved in a non-reactive solvent that contains a catalyst. Then the reaction result in polymer, which is also soluble in the chosen solvent. Heat released by the reaction is absorbed by the solvent, that reducing the reaction rate. Moreover, the viscosity of the reaction mixture is reduced, preventing auto acceleration at the high monomer concentration. Then, a decrease in viscosity of the reaction mixture by dilution also aids heat transfer. Once the desired conversion is reached, excess solvent must be removed to obtain the pure polymer. That accordingly, the solution polymerization is primarily used in application where the presence of a solvent is desired anyway. Next, for the operating condition of the solution polymerization, the first one is temperature need to be between 120 until 250 Celsius. The second one is a pressure. Pressure should be the 1 until 10 MPa. Then the third one is solvent. The solvent need to be a low boiling hydrocarbon. Next we go to the real world example of products and its application, which is the first one is a medical and hygiene application. It is used for the medical bags and fluid pouch, also for the diaper and hygiene film belt sheet. So for the second one is a soft and elastic polyolefin plastomer, which is it is for the footwear, foams and midsoles. The last one is automotive and industrial users, which is a flexible hoses and also protective laminates. Okay, next we go to the advantages and disadvantages of the solution polymerization. So for the first one, we go to the advantages. Okay, for the advantages is a good superior mechanical and sealing performance because it is produced PE grade with high toughness, clarity and also strong heat seals. The second one is homogeneous reaction environment because the polymer remains dissolved, giving good heat and mass transfer. The third one is high flexibility in product design because it is easy to tune molecular weight, branching and comonomer content. And the fourth one is stable operation at elevated temperature. So we go next to the disadvantages for the solution polymerization. The first one is it is higher process cost because it requires solvent purchase, handling, purification and also recovery system. The second one is environmental and safety consideration. The third one is lower catalyst efficiency at high temperature. And the fourth one is operational complexity.
Gas phase polymerization is one of the most common industrial methods used to produce polyethylene, especially high-density polyethylene or HDPE and linear low-density polyethylene known as LLDPE. In this process, ethylene gas, which has the chemical formula C2H4, is polymerized in the presence of a catalyst. The reaction takes place inside a fluidized bed reactor. Inside the reactor, the ethylene gas flows upward and keep the solid catalyst particle suspended, creating what we call a fluidized state. This allows good mixing and efficient heat transfer during the polymerization process. As the ethylene molecules react, long polyethylene chains are formed and gradually grow on the surface of the catalyst particle. These polymer particles are then collected as solid polyethylene powder, which can later be processed into plastic products. One of the main advantages of gas phase polymerization is that it does not require a solvent, making the process simpler and more cost-effective. It is also easy to scale up, which is why it is widely used for large-scale industrial production. In addition, the process provides good control over molecular weight and polymer properties, allowing manufacturers to produce polyethylene with specific characteristics. However, there are also some limitations. Heat removal can be challenging because the polymerization reaction is exothermic, meaning it releases a large amount of heat. The catalyst used must also be highly active and stable to ensure efficient operation. Furthermore, gas phase polymerization is not suitable for all types of polyethylene. For example, low density polyethylene or LDPE is typically produced using a high pressure polymerization method. Ethylene monomer gas and a solid catalyst such as Ziegler-Natta or metallocene are fed into the reactor. An upward flow of ethylene gas keeps the catalyst particles suspended in a fluidized state, allowing polymerization to occur on the surface of the catalyst particle. As ethylene molecules join together, long polyethylene chains are formed, producing solid polymer particles. The reaction operates at temperature between 70 and 110 degrees Celsius and pressure of 10 to 30 bar, and the process remains entirely in the gas phase without to use the solvent. The polyethylene powder is continuously removed, while fresh monomer and catalysts are added, allowing continuous operation. The product is then separated, dried, and pelletized.
So this is the comparative analysis for the 5 polymerization method for polyethylene production. The first one is emulsion, the second one is solution, the third one bulk, and the fourth one suspension, and the lastly is gas phase. So the summary is a gas phase polymerization is the most advantageous method for polyethylene production due to its low cost, scalability, and suitability for producing high volume HDPE and also LLDPE products.
To summarize, there is no single best method to produce polyethylene. Each process has its own advantages, and we choose the method based on the product we want to make. Next, polyethylene production requires balance, good control on temperature, pressure, cost, and catalyst to get good quality polymer. These processes are also important to the industry because they help us create plastics and are stronger, lighter, and more sustainable. Finally, polyethylene will continue to be widely used in many applications with new research and technology as its production will become more efficient and environmentally friendly in the future.